Your eyes are a masterpiece of evolution. Right now, they are performing a miracle, translating electromagnetic waves into a symphony of roughly 10 million distinct colors. From the deep bruise of a sunset to the neon hum of a city street, we feel like we're seeing the full palette of reality. But color isn't actually out there in the world. Color is a hallucination. It's a private vote held by 3 types of light-sensitive cells in your retina called cones. You have a blue cone, a green cone, and a red cone. When light hits them, they send signals to your brain, which tallies the results and creates the sensation of purple or orange. For our entire history, we assumed we were seeing the whole show, but in 2025, scientists proved that we've been living in a biological cage. There is a forbidden color, a shade more saturated than anything in nature, that your eyes have been hiding from you. And for the first time, someone just broke the lock. To understand why you're colorblind to reality, we have to look at a quirk in our history. Most mammals are dichromats. They only have 2 cones. But somewhere along the line, a primate ancestor had a genetic mutation that split one cone into 2. The middle wavelength, green, and long wavelength, red cones. This gave us a massive advantage. We could finally tell the difference between a red fruit and a green leaf. We became masters of the forest. But evolution is a tinkerer, not an engineer. Because these 2 cones evolved from the same ancestor, they are nearly identical. 85% of the light that activates your green cone also activates your red cone. This overlap creates a dead zone in our perception. Because they always fire together, there is no wavelength of light in the universe that can stimulate the green cone without also triggering the red one. We are physically incapable of seeing pure green. Every green you've ever seen, the moss on a tree, the emerald of a gem, is polluted by red. We are trapped inside a limited gamut, a tiny horseshoe of color, while a much larger world of light sits just out of reach. In April 2025, researchers at UC Berkeley decided to stop waiting for evolution. They called their system Oz, named after the Emerald City, that moment in the film when a grey world suddenly erupts into impossible color. The name turned out to be more accurate than they expected. Using a precisely engineered laser rig, they first mapped each volunteer's retina at the level of individual cells, locating every M cone among the millions of photoreceptors packed into a patch of eye the size of a thumbnail. Then the laser went to work. Not on one cell, but on thousands, firing microdoses of light at 105 pulses per second, hitting each M cone as it passed, and staying dark for every L cone nearby. For the first time in the 200,000-year history of our species, the overlap was silenced. The M cone spoke alone. The volunteers sat in the chair and looked into a tiny square of light. What they saw stopped them. They didn't reach for existing color words: teal, cyan, turquoise. They said it felt like those colors had been a pale shadow of something they'd never been allowed to see. The most saturated color in nature looked washed out by comparison. They called it Olo. How do you describe a color that doesn't exist in the physical world? If you look at a screen right now, you aren't seeing Olo. You can't. Your screen is made of pixels that are bound by the same physical laws as your eyes. They can only show you colors within the standard human gamut. The observers described Olo as being supersaturated. To them, the brightest, most vivid colors of a tropical ocean or a neon sign looked pale and washed out by comparison. Olo was a color with the volume turned up to 11, existing in a dimension of light our brains are wired to process, but our eyes are too clumsy to provide. This is the impossible color. It's a reminder that we are seeing the world through a keyhole. We think we see the room, but we're actually just seeing the shapes of the light that manages to squeeze through the gap. The discovery of Olo is more than just a scientific curiosity. It's a proof of concept. If we can use technology to stimulate individual cells, we can begin to expand the human experience. Researchers are already looking at how this could help people with color blindness, not just by fixing their vision, but by giving them access to colors that even normal people can't see. We might one day walk through a world where we see four-dimensional color, where the sky isn't just blue, but a shifting gradient of frequencies we currently don't have names for. We often feel like we've reached the end of our story, that we've mapped the globe and understood the atoms. But Olo shows us that we are still at the very beginning. We are biological beings with sensory limits, but we are also the only species that has learned how to build a ladder to look over the wall. The universe is much more colorful than you're allowed to see. For now, the cage is still there, but we just found the window.